Next topic is Charpit's method. So question is explain the Charpit's method for solving partial differential equation f x y z p q is equal to 0. So let f x y z p q is equal to 0 is 1 be the given partial differential equation in which x and y are independent variable and z is dependent variable. Z is a function of x and y. And so uh, and dz is what? Dava z by dava phi by dava x dx plus dava phi by dava y dy. That is the derivative of this z. Dz is what? Dava phi by dava x dx because phi is the function of x and y plus dava phi by dava y dy. And we can also denote this phi by z, that is dava z by dava x dx, dava z plus dava z by dava y dy. And we know that dava z by dava x is small p, and dava z by dava y is small q. So this is the of the differential equation of the type p dx plus q dy minus dz is equal to 0. And this is the Fabian differential equation p dx plus q dy plus r dz is equal to 0, where p, q are all functions of x, y, z. So in this method, we have to find another relation between f, x, y, z, p, q is equal to 0. This is capital F, this is small f. So we have to find the another relation between this x, y, z, p, q. And suppose that equation is f, x, y, z, p, q is equal to 0, capital F, x, y. This is the equation number 3. Such that the values of p and q are obtained from the equation 1 and 3, make the equation 2 integrable. In such, we have to find this new function, new relation f x y z p q is equal to 0 in such a way that the values obtained from the values of p and q obtained from equation number 1 and 3 by solving equation 1 and 3. If we obtain p and q, then these values are in such a way that equation 2 becomes integrable. If we substitute the values of p and q in equation 2, then equation 2 becomes integrable. So in such a way, we have to find the values of this function relation, new relation f x y z p q is equal to 0. So the solution of equation 2 is complete integral of differential equation 1. So the solution of this equation number 2 is the complete integral of equation number 1. So differentiate 1 partially with respect to x. Differentiate 1 partially with respect to x. So we have differentiate this equation with respect to x. So fx plus the complete derivative is what? Fx dx dava x by dava x is 1. Then fy dava y by dava x is 0. So there is no term fy. So the term fy is absent because x and y are independent variables. So derivative of x with respect to y is 0 and derivative of y with respect to x is 0. And so the second term is what? Fy dava y by dava x is 0. Dava y by dava x is 0 quantity. So the next fz dava z by dava x, that is zx, dava z by dava x is zx, plus fp dava p by dava x is px, plus fq means dava f by dava q, dava q by dava x is 0, or dava q by dava x is equal to 0. So this is the partial derivative of this equation number with respect to x. It is what? The partial derivative of 1 with respect to x is dava f by dava x, dx dava x by dava f by dava, or dava f by dava x by dava x. Then dava f by dava y by dava x. Dava x by dava x is 1, and dava y by dava x is 0. Dava f by dava z by dava x. Dava f by dava p by dava x, and dava f by dava q by dava x. And dava f by dava p is denoted by fp, dava q by dava x is denoted by qx. So this is the derivative of 1 partial with respect to x. Again, similarly, differential equation 3, this is capital F. Either use here small f, and here instead of this capital F, we can also use small g as another notation. So instead of capital F, we can also use small g and then convert the problem answer of the problem. So again, differentiate with respect to this with respect to x, equation number 3. So is what? Dava f by dava x by dava x. That is dava x by dava x is 1, and dava f by dava x is capital F suffix x. Then dava f by dava y by dava x. Dabba y by dabba x is 0 because x and y are independent functions. And therefore dabba y by dabba x is 0. Dabba f by dabba z by dabba x. So it is this term. Dabba f by dabba z means fz. Dabba z by dabba x means zx. Then dabba f by dabba p means fp. Dabba p by dabba x means px. P suffix x plus dabba f by dabba q means fq. Dabba q by dabba x is qx is equal to 0. So multiplying equation 4 by f of p, capital F of p, and 5 by small f of, and subtracting we get. So if we multiply by this f of p to this capital F of p, and this is with small f p, then this term get cancelled. So in order to cancel this term, we multiply this equation number 4 by capital F of p, and equation 4 by capital F of p, and equation 5 by small f of p, and subtracting we get fx capital F of p minus this term fp this multiplication fx plus take zx as common, so fz fp capital fp minus fz f small f of p, take zx common, this becomes 0 term, and from these two terms take qx as common, so fq fp capital fp minus fq capital F2 into small f of p is equal to 0. We have this by using this. Similarly, differentiate 1 and 3 with respect to y. So in this way, we have to differentiate equation 1 and 3 with respect to y. So the derivative with respect to y is again dabba f by dabba x by dabba y. Dabba x by dabba y is 0, so that term is 0. Then dabba x by dabba f by dabba y by dabba y is 1. So the term is fy, dabba y by dabba is 1. Then next term is dabba f by dabba z by dabba x. Dabba f by dabba z means fz. Dabba f by dabba z means fz. And dabba z by dabba y means zy. Then dabba f by dabba p. Dabba f by dabba p means f suffix p. Dabba p by dabba y. Dabba p by dabba y means py. Plus dabba f by dabba q. And dabba q by dabba y, that is fqy is equal to 0. Similarly, derivative of equation number 3 with respect to y is dabba capital F by dabba x. Dabba x by dabba y is 0. Dabba x by dabba y is 0. Then dabba f by dabba y means fy, capital Fy. Dabba y by dabba y is 1. So fy. Then dabba f by dabba z, that is f capital F suffix z. Dabba z by dabba y. Dabba z by dabba means zy, this term. Similarly, dabba f by dabba p by dabba y, dabba f by dabba q by dabba is equal to 0. And if, now we have to eliminate this term. So multiplying equation 7 by this fq, and the 8 by this small f of p, f of q, small f of q, and subtracting, we get this term get 0. And then fy, fq fy, because we have to multiply this by fq, so fq fy minus fy fq fy, small fq fy, and this from these two terms find take zy as common, so fz f of q minus fz f of q, and from these two take py as common, so fp capital F of q minus f of q capital F of q small f of q is equal to 0. This is equation number 9. So we know that py or p suffix y means dabba p by dabba y, and dabba p by, that is dabba y. P means dabba z by dabba x. Dabba z small p means dabba z by dabba x, and it is dabba square z by dabba y dabba x. Now this py becomes, and dabba square z by dabba x dabba y. Dabba square z by dabba x dabba y. Dabba y dabba x is dabba square z by dabba x dabba y, and it is dabba square z by dabba x dabba y. Take dabba x as common, so dabba z by dabba x, it is dabba x of dabba z by dabba y, this quantity, and dabba x of dabba z by dabba y is q. So this is qx now, this qx. So p suffix y is qx. P suffix y is qx. So using equation 10 in 9, we get this. We have to use this small py as qx in 9. So small py as qx. Substitute this small py as qx. So we have this 11 number, equation number 11. So just here py, substitute py as qx. So this is the 11 number. Then adding 6 and 11. This is the equation 6 and 11. We have to add these two equations. So we have uh, fx fp minus fp fx, that is equation 10, equation 6. Equation 6 is this. So fx fp fx plus zx plus zx, equation number 6, this quantity. Zx, this quantity, plus this quantity fy fq minus equation number 10 fq fy minus fq fy, this term, plus this term, and observe this term qx fp fq minus fp fq, and observe this term, equation number 6, qx in bracket small f of q, f of capital F of p, and here the term, it is positive, f of p, f of q. So the addition of these two terms is 0, this term and this term. So if we take negative sign common, then we have minus qx, f of p, f of q, capital F of p. So this is capital F of p, f of q. So these two terms, qx in bracket this term in 6 and this term qx, both are same and opposite sign, so it's become 0. Addition becomes 0. So we have these two terms, and in equation number 6, these two terms as the resultant equation. This is the equation. Okay. Now we write this as this capital F suffix x in bracket minus f of p. Then capital F of y. Where is the capital F of y term? This is the capital F y term minus f of q. Then capital F suffix z, and the term is what? Capital F of f suffix z is this minus zx fp and minus zy minus zy fq, and then capital F suffix p, the terms of capital F suffix p. So this is the term fx plus zx into fz, this term, and then capital F suffix q, the terms are this fy plus zy fz, this term is equal to 0. So collect the coefficient of f suffix x, f suffix y, f suffix z, f suffix p, f suffix q, and then we have, this is the fz, then f of p fx, this right zx as small p and this zy as small q, right here zx as small p and zy as small q. And then the auxiliary equation of given differential equation are dx by minus f of p, dy by minus f of p. So dz by minus p f of p plus q minus q f of q, take minus sign common. So p f of p plus q f of p, dp divided by this fx plus zx, fx plus p fz, dq divided by fy plus q fz. So this is the auxiliary equation of the given differential equation. The given differential equation is this. So we have this auxiliary equation from this. Dx divided by minus f of p, dy divided by minus f of q, dz divided by this, dp divided by this, and dq divided by this. And that is, we can also change the negative sign. So we have dx by fp, dy by fq, dz by p fp plus q fp minus dp divided by, so negative effect of negative, divided by fx plus f of p f of z minus dq divided by fy plus q f z. So this is equation number 12. And so from equation number 1 and 12, we obtain the values of P and Q. And using these values of P and Q in the equation number 2, what is the equation number 2? dz is equal to P dx plus Q dy. This is equation number 12. 2. dz is equal to P dx plus Q dy, or this equation. dz is equal to P dx plus Q dy. So from equation 1 and 12, find the values of P and Q and use these values in the equation number 2, means dz is equal to P dx plus Q dy, and integrating that equation, we get the required solution, or solve that equation. dz is equal to P dx plus Q dy, solve that equation, we get the general solution of the given differential equation. So this is Charpit's method. So we have to solve the problems on Charpit's method. Solve this problem: P square plus Q square y is equal to Qz by Charpit's method. So this is the given differential equation. So we write f x y z p q, or small f is equal to P square plus Q square y minus Qz is equal to 0. So write the given differential equation in this form: small f x y z p q is equal to 0. F is the function of x, y, z, p, q. So this f denote f by f, this function p square plus q square y minus qz. What is this f? F is the function of x, y, z, p, q. So this is the given problem. So denote by small p, small f as the function p square plus q square y minus qz is equal to 0. Then write the auxiliary equation. The auxiliary equations are, so write the auxiliary equation: dx by fp, dy by fq, dz by pfp plus qfq, minus dp divided by fx plus pfz, minus dq divided by fy plus qfz. And so substitute the values. So this is the given equation number 1. And this is 12. We have to find the, from 1 and 12, we have to find the values of p and q. So this is equation number 12, auxiliary equation. Then what is fp? Fp is the derivative with respect to p is 2py. The fq is 2qy. Fz is 0. Fz is minus, fx is 0 because there is no x in this f. Fy is p square plus q square. And fz is minus q, the derivative with respect to z, partial derivative with respect to z. Substitute these values. So the auxiliary equation becomes dx divided by 2py, 2qy minus z, dz divided by this p into fp. P into fp is this 2p square y, plus q into fq is this, minus dp divided by fx. Fx is 0. So plus p fz. Fz is, so we have minus pq, minus dp divided by minus pq, minus dq divided by fy is p square plus q square, plus q into fz. So it is minus q square. So write this plus minus q square, p square plus q square minus q square. And then dx divided by, the simplification is this, minus pq minus become plus dp divided by pq. And this p square plus q square minus q square is p square minus dp divided by q square. So this is the auxiliary equation. And now we have to consider the 2 ratios out of these 5 ratios. So consider dp divided by pq is equal to minus dq divided by p square. So we consider the 2 ratios in which if you consider dp and dq, then it is independent of other variables x, y, z. If you consider dx and dp, suppose first ratio and this fourth ratio, then check whether it is independent of y, q, and z. So take the 2 ratios dp by pq and minus dp divided by dq divided by p square, because these 2 ratios are what? Are independent of x, y, z. Only depend on p and q. So if you consider dx and dp, when we consider the first ratio dx and dp, if these 2 ratios are independent of other variables, that is, it only contains the x and p. When you consider dx and dy, these are independent of pq, but we have to find the value of p and q. So consider the 2 ratios, either first ratio and fourth ratio, or first ratio and fifth ratio, or second ratio and fourth ratio. So we consider this, cancel P. So we have dP by Q is equal to minus dQ divided by P. And so after simplifications, P dP is equal to minus Q dQ. And so after integration, we have integrating both sides. So integration of P with respect to P is P square by 2 and minus Q square by 2, integration of Q with respect to dQ with respect to Q, plus constant of integration, suppose C1 or C, and then multiplying by 2, we have P square minus is equal, plus Q square is equal to 2C. Suppose 2C is C1, new constant. So this is equation number 2. And so putting this equation number 2 in 1, now we have to find the value of P and Q. So putting this equation 2 in 1, we have P square plus Q square as C1y is equal to QZ is equal to QZ. And therefore Q is equal to C1y by Z. So we have the value of Q. And so this substitute this value of Q as C1y by Z in equation number 1. In equation 1, we find the value of Q. So substitute in equation 1 or equation 2. Substitute this value of Q in equation 1 or equation 2. If we substitute this value of Q in equation number 2, then we have P square plus Q square, C1 square, Y square by Z square is equal to C1. And so P square is equal to C1 minus this quantity. Take Z square as LCM. So we have Z square C1 minus C1 square Y square. And then P is equal to take square root of both sides. So root in root Z square C1 minus C1 square Y square divided by Z square. And this is the root of Z square is Z. So write square root of numerator divided by square root of Z square as Z. And then consider the differential equation dz is equal to pdx plus qdy. So from equation number given equation 1, the given equation is 1, and this auxiliary equation we have to find the values of p and q. So we have this p and q. P is this and q is this. So consider the differential equation dz is equal to pdx plus qdy, and then substitute p as this root z square c1 minus c1 square y square divided by z dx plus q is cy divided by z dy. And we have to solve this differential equation. So multiplying throughout by z, we had z dz is equal to root c1 square z square minus c square y square dx plus c1 y dy. And so this is the actually the Papian differential equation. So use one of the method that is applicable to this Papian differential equation. So there are many methods to obtain the solution of Papian differential equation, either by using variable separable form or by using different tricks that is given in that topic, Papian differential equation, or it is one variable separable. This is one variable separable now. This is one variable separable. So shift this term to LHS and divide this. We have z dz minus c1 y dy, and then shift this term. It is multiplied to dx. So it is after shifting to LHS, we have divided by c1 z square minus c1 square y square is equal to dx. So this is one variable separable. This is the type of Papian differential equation, one variable separable. And another types are homogeneous Papian differential equation or Nathan's method, or by using the tricks we can obtain the solution of Papian differential equation. That is either the given differential Papian differential equation is three variable separable or one variable separable, or homogeneous Papian differential equation, the type of Papian differential equation. So this is the Papian differential equation where to obtain the solution of this differential equation by using one of the method that is used in the topic Papian differential equation. So here we have this, and then the derivative of this quantity root this is the derivative of 2 times root c1 z square minus c1 square y square. So what is the derivative of this quantity? Root c1 z square minus c1 square y square is 1 by 2 times root, this 2 times root into derivative of this quantity. Into derivative of this quantity is what? Is a c1 z dz minus 2 c1 with derivative of this quantity bracket. So is what? C1, and the derivative of z square is what? 2z dz. So that is 2c1z dz. And the derivative of this quantity is what? Minus c1 square is constant, 2y dy, 2y dy. So this quantity. So just multiply by 2 and divide by, throughout multiply by 2. Where multiply by 2 to LHS and multiply to RHS. And so we have, here is like 2 dx only, not c1, 2 dx. So multiply by 2. And then integrating both sides. So this is the 2 time, this is the derivative of 2 time root c1 z square minus c1 square y square. So what is the derivative of this quantity? Is 1 by 2 time, what is the derivative of this quantity? 1 by 2 time this into derivative of this quantity is 2 times this. So this is 2 to get cancelled. So I get this 2 and is equal to, and this right here 2 dx only, not c1. And so what is the derivative of 2? Yes, yes, yes. So multiply by 2c1 both sides. Okay, not only 2c1 z minus c1 square. We are right 2c1 square, right? After multiplication of 2c1 both sides, we have 2c1 z dz minus 2c1 square. Right here square, because c1 into c1 is c1 square. So right here c1 square y dy. So it is the derivative of this root quantity. And therefore, we have 2c1 x is the derivative of this integration of 2c1. 2c1 is constant, and the integration of 2c1 is 2c1 into x plus c2 as the new constant. And then cancel through 2, that is dividing by 2. So we have this root c1 z square minus c1 square y square is equal to x c1 plus 2c2, and let it be c2 dash, new constant, 2c2 as c2 dash. And this is the general solution of the given differential equation. So this is about the Charpit's method. So we will see the remaining problem in the next lecture.